in terms of average, class average, kayo yung may pinakamataas sa sa 5 classes na nagte-take ngayon ng fluid machinery. So that's a good sign at least. Then before we start on our next topic, refresh lang and review ng previous topic. So, na-discuss na natin last time ang fluid flow in pipes, including the fluid properties. So, fluid properties, hindi lang to regarding sa water, hindi lang water yung dumadaan sa ating pipes. Meron ding iba't ibang klase ng fluids like oil. Last time nga, nag-sample tayo ng glycerin. So, depending on the fluid properties, mag-iiba rin yung ginagamit natin parameters such as specific weight ng fluid. Then, when it comes to fluid flow in pipes, so discuss natin yung um, energy balance sa pipe section. So, yung energy in is equivalent to energy out and other parameters. Then, for the discussion of the pumps, let's try to connect those fluid properties, those fluid flow in pipes sa first fluid machinery. Since this is fluid machinery, yung first fluid machinery na pag-aaralan natin is yung tinatawag na pumps. So since may idea na kayo from the last semester kung ano yung definition ng pump, so basic definition lang ulit or refresher, the purpose of a pump is to transfer a fluid from a region of low pressure to another region at the same or higher pressure. So kapag pinag-uusapan natin si pump, based from our last discussion, we're discussing the fluids and fluids flow in the pipe. Let's try to connect those fluid flow in pipes din nga sa ating first fluid machinery na pag-uusapan, which is the pipe. So, parts ng pump natin includes the suction part, o yung papasok sa ating pump, yung tube or yung pipe na papasok sa ating pump, and discharge pipe, ito kung saan dinadala o yung transferring the fluid to another region at a higher pressure, yung ating fluid. Then, we have the impeller, together with our casing. Na-explain naman natin to last time sa parts ng isang rotodynamic machine. Along with that, yung nagpapaikot or nagko-convert ng electrical energy sa rotational energy, which is yung motor natin. So yung purpose ng motor is in Tagalog, patakbuhin or turn on yung ating pump. Nagko-convert ng electrical energy into rotational energy or mechanical energy. So pag-uusapan natin sa following slides for the next 3 hours, ang parameters or ang details regarding the motor, regarding the pump, the suction, and the discharge. So part of our refresher is the energy balance in our pump. So same as before, refresh lang, this is part of Bernoulli's equation, na-derive siya sa Bernoulli's equation. So energy in will always be equal to energy out. Energy in, makikita natin on the left side of the equation. Energy out, yung sa right side naman ng equation. So part ng energy in natin is yung pump work, yung tinatawag na total dynamic head. Mamaya madi-discuss natin what is total dynamic head. Pero for now, let's discuss or let's associate it with the term as pump work. So, pump work plus all the energy na papasok sa ating pump, including the kinetic energy ng fluid, pressure energy, and potential energy or elevation head na papasok sa ating pump is equivalent dun sa energy na palabas. Energy na palabas, meron siyang component na same velocity energy or kinetic energy, pressure energy, elevation, and friction losses. Okay. So before we define the total dynamic head or the head developed in a pump, since we know that in Bernoulli equation, we have two forms. The one we call the head form or in meters or the energy forms or in pressure. So the energy and head developed in a pump, i-explain natin dito graphically and figuratively. So as you can see on the left side ng ating photo or ng ating slides, so this is a figurative representation ng ating general pumping system. While on the right side is a graphical representation naman ng equivalent na energy and head developed in a pump. Para magkaroon kayo ng overview kung what is the meaning or what is really meant by the total dynamic head. So from the reservoir at level A, inverted triangle symbolizes elevation of the fluid. So before pumasok pa yung fluid natin papunta sa suction flange, dito sa part B, there will always be corresponding losses na kagad. So represented that by H sub in. So bumaba ang ating energy or bumaba yung energy ng fluid or yung head developed ng pump from A to B due to losses associated with or we can call that H sub E. Then alam naman natin na kapag ang fluid is dumaan sa pipe going to suction part or inlet part ng ating pump, magkakaroon tayo ng additional losses. So from B to C, we call that H sub F1. This is equivalent also to makukompute natin using Darcy-Weisbach equation or major losses. Then ang purpose nga ni fluid is to provide energy, ang purpose nga ni pump is to provide energy sa ating fluid or to increase the total head developed or total dynamic head. So from C to D, tinaas ni pump ang energy ng fluid or ng head developed from this point, the lower level C, going to point D. Then from point D, going to the discharge reservoir, dumaan na naman tayo sa pipe. So may corresponding losses na ulit yan, which is HF sub 2, which can be calculated using the Darcy-Weisbach equation. So from the discharge plunge ng ating fluid, from E to F, there's corresponding losses ulit, which is represented by H sub E. So dinidefine lang dito yung total dynamic head na kailangan ng ating pump para ma-transfer natin yung fluid at reservoir at point A yung system or pump system. So the total dynamic head is the pump total head, represents the energy added to the fluid by the pump between the suction and the delivery nozzle per unit weight of fluid. So yung total dynamic head daw natin, or simply termed as TDH, is composed of 4 elements added together. The first one is the elevation differential. Kinuha lang naman natin yan dito sa Bernoulli's equation. I-paste ko lang dito sa ating next slide. So the elevation differential is called the static head. So before sa pump or sa pipe, gumagamit tayo ng reference as 0.1 or 0.2, where we subdivide the pipe, or we cut the pipe into one segment to determine the head losses or the energy flow and energy balance inside it. Pero when we're dealing with pumps, what we're gonna do is to associate it with the discharge and suction. Hindi na tayo gagamit ng um, point A to point B or point 1 to point 2. So again, one of the four components na meron ang total dynamic head is the elevation differential, which is called the static head, between the discharge and the suction port. So this is the discharge, this is the suction. The pressure differential called as the pressure head. So the difference in pressure in the discharge and in the suction. So makikita natin na connected tayo sa isang pump. There will have a pressure gauges before and after the pump natin. So this is a pressure gauge. So anything na ma-register or makita sa pressure gauge will be in gauge pressure lang. So the difference in pressure between the discharge and suction, i-add din natin siya para makalculate yung total dynamic head. And again, the liquid velocity energy or losses is called the velocity head. So for a compressible fluid like water, we know that the volumetric flow rate going inside is equivalent to volumetric flow rate going outside or the discharge port. So para kukunin natin si velocity, Q is equivalent to area multiplied by velocity. Magbabago ang velocity depende kung ang area ng ating suction and ang area ng ating discharge flange is magkaiba. So kapag magkaiba sila, there will be a difference in velocity or there will be losses between the suction and the discharge part. Pero kung parehas lang sila ng area, parehas sila ng diameter, then we can cancel this both. Pwede natin cancel yung velocity difference kasi wala naman silang difference talaga, zero lang. Last one is the friction energy or loss is called the friction head. Here is HL. If hindi given sa problem si friction head, then let's cancel this one or make it zero kasi hindi siya available. So energy and head flow in a pump, by context, basahin lang muna natin siya, static head. So if you're pumping from down going up, that elevation difference is what we call the static head. There are few slides here na merong or ma-define natin ano ba yung tinatawag na total static head or discharge static head and suction static head. Kung saan na tayo marito when we're dealing with what we call total dynamic head sa total static head. Magkaiba sila. Component lang ni total dynamic head si total static head. The total static head, madiderive lang to or makukompute natin based on the elevation difference, suction and discharge part. So static head, ayun nga, the elevation change or difference between the suction part and the discharge part, while the pressure head is the pressure change across the system. If both the suction vessel and the discharge vessel are exposed to the same pressure, then there is no pressure differential and no HP to consider, H dash P. So kapag walang binigay or if they if the pressure here in the suction is equivalent to the pressure on the discharge, then there will be no pressure change and makakancel lang naman sila in the equation. Wala tayong kailangan i-calculate doon. So velocity head, creating and maintaining liquid velocity in the pipes also consumes additional energy that must be designed into the pump. We need to know the velocity of the liquid in meter per second moving through the pipes and the acceleration due to gravity, because the acceleration due to gravity is constant and the velocity head rises and falls with the liquid velocity. So in this equation, to determine the velocity head, dinivide natin siya sa acceleration due to gravity. Since acceleration due to gravity is constant lang, ang difference in uh, velocity head is magdedetermine lang or will be dependent lang sa value ng velocity at suction and the discharge. And since volumetric flow rate is the same, then yun nga, mag-iiba or magiging dependent to sa value ng ating area ng pipe. Finally, the friction losses. Well, as defined on our first meeting, the friction losses refer to the friction between the liquid and the internal surfaces of the pipes, valves, and fittings. The friction in the pipe reduces or drags down the ability of the pump. Friction losses must be designed into a pump so that the pump will overcome the frictional losses in the system. So every difference in pressure, every difference in elevation, every difference in velocity and the friction losses in the system, kailangan natin i-design yung pump natin to overcome those values. So kailangan natin makalculate yung exact, not really exact, kailangan natin makalculate yung required total dynamic head para makapag-provide tayo ng proper sizing ng kung anong pump yung gagamitin natin. Later on, makikita natin yung pump analysis. So hindi lang pump yung kailangan natin i-design, even the motor na naka-accompany dun sa pump, kailangan din natin siyang i-design. So technically, yung purpose, yung objective natin ngayon is para malaman ano yung mga parameters na kailangan nating maalala, ma-remember whenever we are designing a pump or whenever we are designing a system involves pump and pipes. So we can further convert this equation, this energy balance equation, into this equation. Total dynamic head is the difference between the elevation on the discharge the uh, between the discharge and the suction plus the velocity difference in discharge and the suction plus all the losses or frictional losses in our system. So essential na makuha si total dynamic head kasi makakatulong to determine what we call the power ng fluid. Then later on, makukompute natin sa fluid power, then brake power, then motor power. So malalaman natin yung right sizing ng motor, kung ano yung motor rating na i-apply natin o nabibilihin natin. Pati yung proper sizing din ng ating pump, kung ano yung pump rating na bibilihin natin. Okay, so for pump analysis, Okay, so for pump analysis, na-compute natin, na-determine natin kung paano mako-compute si total dynamic head. So si total dynamic head can be associated with what we call the fluid power. So, pamaya makikita natin yung equation ni fluid power using the total dynamic head. So we will use this energy flow chart later on sa mga equations natin pamaya para madali natin maintindihan at para madali natin ma-analyze. So let's start with the motor input muna or the motor power input. Here at the left side ng ating flowchart. Kasi motor power input, ito yung motor rating na tinatawag. Ano yung ano yung power ng ating motor in kilowatt hour o in HP, depende sa kung ano yung binigay sa catalog. So makikita natin to dun sa catalog ng mga supplier, ano yung available sa market or off the shelf sa market na mga motor. So kapag magde-design tayo ng pump arrangement, kailangan natin ma-determine ano yung required power natin para papatakbo yung ating pump nang hindi naman tayo loss or hindi naman ko-consume ng power na more than sa nire-require ng ating system. Means, pag ano kasi, additional losses yan, additional cost, or proper sizing lang, sakto lang or enough lang sa requirement ng ating system. Kasi kapag kulang din ang power, then hindi natin mapapatakbo on the required capacity yung pump. So pag may na-compute na tayong value, halimbawa na-compute natin na 2.6 or 2.7 HP pero wala naman sa market or wala namang off-the-shelf na value na 2.7 HP, then we will go to the next higher rating ng motor na bibili natin. So yung motor power natin, ito rin yung tinatawag na power supply. Or, okay, in common terms, yung electricity na tinatawag. So ito yung susupply ng power sa motor para mapatakbo yung ating pump. So from this side, papatakbuhin ng motor ang ating pump. Pero before that, yung output ng ating motor will be the input ng ating pump. At ito yung tinatawag na brake power or we can call it BP. Here is the motor power. So yung input ng ating motor is what we call the motor power. Yung output naman is what we call brake power or BP. Based from this figure, we can say that the motor power is always greater than the brake power. Or the motor power is equivalent to brake power plus the motor losses. Since hindi naman perfect yung system natin, yung ating mga motor or anything, lagi may friction yan, there will always be losses involved. So from this side to this side, everything here is related to motor. Then we'll jump to pump naman. So from this side going to this side. So yung output ng motor, we call that brake power, which will be the input ng ating pump. So sa pumping arrangement, we have what we call here as power imparted to fluid by the impeller. So ang purpose ni motor is to convert the electrical energy into rotational energy or mechanical energy, tama? So once na napaikot ng motor natin ang propeller or what we call impeller, sorry, propeller is for the turbines and then impeller for the pumps. Then we have what we call here as the power imparted to fluid by the impeller. It's designated by or denoted by PISP. Sometimes, sa problem, hindi na pinapahanap si power imparted to fluid. Minsan, from the brake power, directly or considered na after that is the fluid power o yung output ng ating pump. Kasi in between the brake power and the fluid power, makukompute na rin naman natin yung losses, isang losses na rin siya i-consider natin. Pero if hinanap sa problem yung tinatawag na power imparted to fluid by the impeller, then later on may equation tayo para makalculate yan. Then lastly, yung fluid power naman, yung output ng power imparted to fluid by the impeller will be the fluid power. So we can say that the brake power is always greater than the fluid power. Or brake power is equivalent to fluid power plus all the mechanical losses. Mechanical losses, disc friction losses, hydraulic friction losses, and leakage flow losses. So kapag binigay sa problem yung tinatawag na leakage flow, then associated yan with the power imparted to fluid by the impeller. So sometimes, magiging approach natin dito when solving a problem is that we are given the power input, then we need to find the fluid power or the, we need to find the fluid power. So yung approach natin is from the motor power input going to brake power and going to fluid power. Pero minsan naman, baliktad, we need to determine first the total dynamic head, then finding the fluid power using the equation, then determining at last what will be the motor rating or the motor power required para mapatakbo natin yung pump dun sa problem. So again, ang objective natin is to know the parameters na kailangan nating malaman whenever we are designing a pump or whenever we are designing a system that involves pump or pipes. So ito yung example ng ating motor and pump nameplate. So on the left side of your screen, ito ang nameplate ng sample ng motor. And on your right side would be the nameplate for the pump. Excerpt lang to sa internet, pero sa catalog ng mga supplier, makikita natin yung complete details ng ating mga pump and motor. So, for example, dito sa motor, given dito yung tinatawag na power rating or motor rating in kilowatt. Sometimes it will be in HP. Ito yung motor rating natin. Given din dito yung efficiency ng pump. So, binibigyan din siya ni supplier o ng designer. Given the rotational speed ng ating motor, efficiency ng motor is given din. Rotational speed ng motor in RPM, revolution per minute. On your right side naman is the pump nameplate. Wherein given dito, or makikita natin dito, ang revolution per minute ng pump, rated niya is 2,900. Same din sa power rating niya, which is 1.5 kilowatts. The volumetric flow rate, makikita natin dito in 620 liters per minute. Sometimes it will be given in cubic meter per second. And lastly, the Hmax or total dynamic head ng total head ng ating pump available din dito or mabibigay sa catalog. Supplier. So, kung magse-select tayo ng right pump, we just need to design first ano yung required na total dynamic head, ano required na power natin para dito. Then, saka tayo pipili sa catalog or saka tayo pipili sa mga supplier ng right sizes ng ating pump or ng ating motor. So, fluid power, based from ating energy flow kanina. So, pinis ko lang siya dito. Ang fluid power natin, it will be the pump output na tinatawag. Related nga siya sa total dynamic head kasi yung equation to get the fluid power is the specific weight multiplied by the volumetric flow rate. So, the theoretical power necessary to raise a given volume of liquid from a lower reservoir to a higher elevation is called the fluid power. Total dynamic head, using our energy balance in the pump, makukompute natin siya. Z sub D minus C sub S plus the difference in pressure between discharge and suction plus the difference in velocity between the discharge and suction plus all the losses involved in the system. So kapag hindi binigay si losses, let's just make it zero. Then the volumetric flow rate is the product of the area and velocity of the liquid that passes through a given surface per unit time. So volumetric flow rate is equivalent sa suction and sa discharge kapag incompressible yung fluid. And ang area ng i-consider natin dito is yung diameter ng suction and diameter ng discharge. So if parehas lang sila ng area or ng diameter, then magiging zero lang to. It will just be zero here. How about the specific weight? Paano natin kino-compute sa specific weight? Plus anyone? Paano kino-compute again si specific weight?
Density times gravity.
Clear ba yung ano ko? Yung pagsasalita ko, naririnig nyo naman ng ayos.
Yes po, sir.
Yes po, sir.
Okay. So, sa pagkuha ng ating specific weight, it will be density multiplied by acceleration due to gravity. So, mag-iba ang ating specific weight depending on the fluid na dumadaan sa ating pipe. Kapag tubig siya, then usual lang, density is 1,000 multiplied by 9.81, then divide by 1,000 again to make it in kilonewton per cubic meter, which is 9.81 kilonewton per cubic meter. Pero mag-iiba to, depende sa anong fluid na dumadaan sa ating system. So next is what we call the power imparted to fluid by the impeller. So equation niya almost the same lang naman kay fluid power. Yun nga lang, nadagdagan tayo ng additional details here, which is what we call the discharge flow of the pump. Kung i-recall natin, si fluid power is equivalent to specific weight multiplied by the actual volume flow rate multiplied by total dynamic head. Dito, mag-a-add tayo ng discharge, leakage flow at pump dun sa discharge flow or actual flow ng pump. So kapag inalis natin to, si leakage flow ng pump equivalent to kay fluid power. Pero minsan pinapakompute sa atin si power imparted to fluid by the impeller. So we need to determine muna yung tinatawag na leakage flow ng pump. I-add lang natin siya sa discharge flow of pump or actual flow rate. Then we can get already the value ng power imparted to fluid by the impeller. So given this condition, we can say that power imparted to fluid by the impeller is greater than the fluid power. Or power imparted to fluid by the impeller is equivalent to fluid power plus all the corresponding losses such as the hydraulic friction losses and the leakage flow losses. So fluid power plus all these losses is equivalent to power imparted to fluid by the impeller. Next will be what we call the brake or shaft power. So we're done with the fluid power. Let's put it at item number 1. Power imparted to fluid by the impeller. Item number 2. Then the fluid power. So everything from this side going to this side is associated with the pump. Again, the brake power or shaft power is the output ng motor and the input naman ng ating pump. So how to get the brake power? It is power imparted to fluid by the impeller plus all of the corresponding losses such as mechanical losses and disc friction losses. Another way to calculate the brake power is using the pump efficiency. Since we know that the input ng pump is the brake power and ang output ng pump is the fluid power, makakalculate natin si pump efficiency using this equation. So pump efficiency is equivalent to fluid power divided by the brake power. So kung given si pump efficiency, at hinahanap natin si brake power, then kailangan mo natin hanapin si fluid power. Then we just need to divide the fluid power by the pump efficiency and we can get the value of the brake power or vice versa. Kapag hinahanap natin si pump efficiency, then we need to know the fluid power and know the brake power, divide them both, then we can get the value of the pump efficiency. We know that when calculating efficiency pala, it needs always to be multiplied by 100 to make it in percentage. Hindi nyo kakalimutan yun. Efficiency as well, we can say that output divided by the input. So in our pump arrangement, yung papasok at yung palabas is given din. Yung palabas sa pump natin or what will be the output will be the fluid power. Yung papasok naman na energy is what we call the brake power. So to get the efficiency, we just need to divide the output divided by the input or divide the fluid power into the brake power. While for motor power, to determine the value for the motor power, we just need to add the brake power to all the motor losses in full. So it will be item number 4, brake power plus all the motor losses will be the motor power. Aside from dividing the fluid power into brake power to get the value of the pump efficiency, there is also another way to calculate that by multiplying the volumetric efficiency, hydraulic efficiency, and mechanical efficiency to get the value of the pump efficiency. But mostly naman, ito yung ginagamit natin. Pero please remember also this equation. Okay, so for motor efficiency, since the output ng motor is the brake power and input ng motor is the motor power, and we know that calculating efficiency is equivalent to output divided by input, then motor efficiency will be this brake power divided by the motor power. Every time efficiency needs to be multiplied by 100 to make it in percentage. And the value shall always be less than 100. Kasi if it's more than 100, then may mali sa ating calculation. Laging mas malaki ang input kaysa dun sa ating output. In the overall pump efficiency, we just need to multiply the efficiency ng pump sa efficiency ng ating motor. So we can get the value of the overall pump efficiency or overall system efficiency. So i-multiply natin yung nakita natin or nakuha natin yung value ng efficiency ng motor dun sa value ng ating pump. May question pa tayo dito before we move on our next topic?
Wala na po, sir.
Okay. Actually, medyo hindi clear yung naririnig ko sa inyo. So, kapag may question kayo, just you can type in our in message up here, in call messages, para mabasa ko na lang. Then I'll try to respond. Medyo hindi ko naririnig ng ayos eh. Okay, so for the typical pump installations, kanina we discussed already what is the total dynamic head. Ngayon naman, we will discuss what is a total static head. By the way, let's go back to this form para lang hindi tayo malito kung ano ba sa total dynamic head, total static head. Kasi pamaya, we still have another type of parameter in determining or sizing the pump. It's called the net positive suction head. So total static head is just composed of these two variables, the elevation at the discharge minus elevation at the suction. We can call that as total static head. So total static head is just a component that needs to be added into the whole picture to get the value of the total dynamic head. Wag tayo malilito, total static head is only related sa elevation ng suction and elevation ng ating discharge. Well, total dynamic head is the totality ng lahat ng components involved such as elevation, pressure, velocity, and friction losses. So from this equation, total static head is equivalent to C sub D, or elevation at the discharge, subtracted by the elevation at the suction, which is C sub S. So for our example A, this is called the static suction lift submerged discharge. When we're discussing about pumps, our center line or our reference line will be the center of the pump, denoted by CL. So anything above this center line or above this reference line, ang sign niya will be positive. Then anything na below sa reference line, ang magiging sign niya is negative. We will use this equation, C sub D minus C sub S, para hindi tayo magkamali when calculating the total static head. So given this problem or given this example letter A, static suction lift and submerged discharge. So the static discharge head is positive kasi above siya sa reference line. So ito siya, it will be positive. We won't change any sign here kasi positive na naman talaga siya. Then the static suction head naman is below the reference line. Kung ito yung reference line natin, at ito yung elevation ng ating water. So inverted triangle, elevation, elevation. Since nasa baba siya ng ating reference line or ng center line, ang magiging sign ng ating C sub S will be negative. Huwag tayo malilito dito. So total static head will be C sub D minus negative C sub S, which is equivalent to C sub D plus C sub S. So moving to the next one, the static suction head and submerged discharge. Ang difference nila is the static suction head and static discharge head are both at the top of our reference line. And here will be top. So ang unit niya dito or ang sign niya dito is positive. Ang sign niya on the other side will be positive as well. Ang kukunin nating reference ng elevation ng tubig is always at the top of the water. So to calculate our total static head, then C sub D, which is positive, minus positive C sub S. So isusubtract lang natin si C sub D minus C sub S. So dito sa dalawa, ano palagay nyo ang mas malaking value na makukuha ng total static head? The first one or the second one? Plus, palagay nyo mas malaki ba makukuha ng total static head on the first one? Kasi inad natin si static suction head to the static discharge head. While to sa second one, sinubtract natin si static suction head kay static discharge head. Bakit kaya ganon? Please remember or um, please understand that our elevation is related to what we call the potential energy. So potential energy, ang equation niya is mass multiplied by gravity multiplied by the height. So same lang din yun. So at this part, kapag yung elevation ng ating suction ay itinaas natin or inelevate natin above the reference line, then yung potential energy niya from zero on the reference line is nag-increase din depending on the height of our static suction head or ng elevation ng tubig. So mas mataas yung potential energy dito sa side na to in compare kapag ang elevation ng tubig is below or ang elevation ng reservoir is below our center line. So assume natin na dito is zero ang kanyang potential energy while here will be zero plus kung ano yung static head ng tubig. Meaning, mas maraming power, mas maraming energy ang nire-require ng pump para madala yung fluid from this point going to this point. Unlike sa situation na to, sa static suction head and submerged discharge on letter B case, mas kokonti yung require na power or ng energy ng pump para ma-push yung tubig from this part going to this part. Kasi yung fluid natin, there's already a corresponding potential energy along with the fluid flow. So mas less yung kailangan ng pump na energy para madala yung tubig sa letter B compared to letter A. So yun yung fundamentals behind the total static head. Pero to make it easier, let's just use this equation and determine yung location ng ating static suction head and static dynamic head. So anything na above the center line will be positive, anything below will be negative. By the way, wala naman sigurong discharge head na nasa baba, or kung meron man, then let's make it as negative yung value ng ating discharge head dito. So there will be 3 more types of typical pump installation. Pero basically, pares lang din naman sila ng principle. So anything na above will be positive. Anything below will be negative. So for this case, it will be C sub D plus C sub S. And ang ating maging reference line dito will be the elevation ng fluids. So regardless kung siya ba is free discharge, you can see here the flow. The flange here is free discharge, meaning di naka-submerge yung tubig. Ang kukunin pa rin nating elevation reference will be the elevation of the fluid. Even here, the elevation ng fluid. So, static suction head and varying discharge, same pa din, anything above is positive. Kukunin nating elevation is yung elevation ng ating fluid. Clarification, questions before we move?
And so far po.
Okay, thank you. So, we will discuss what we call the pump specific speed. Kanina discuss natin yung fluid power, total dynamic head, motor efficiency, motor power. Magagamit natin yan to determine or to calculate or to decide the right sizing or right size ng ating pump. Pero hindi lang naman fluid power, brake power, motor power yung kailangan natin ma-compute. Additionally, we need to determine or we need to know the pump specific speed. Pero ang tanong is bakit? Let's just define first what is specific speed. So specific speed, sometimes called as pump specific speed, is a dimensionless rating for centrifugal pump performance. So this is for centrifugal pump performance lang daw. Although it is not actually a speed, it depends on the shaft speed and is also a function of the flow rate and differential head at the pump's best efficiency point. Specific speed is an important factor in the design and selection of pumps, especially pump impellers. So ginagamit si specific speed kailan? When selecting a pump for a particular application, and knowing that the shaft speed, flow, and differential head, a calculation of specific speed will identify the impeller shape most suited for the task. So kung kanina, calculate natin ang fluid power, motor power, for us to determine or to know the right sizing ng ating motor and ng pump. Ngayon naman, we need a specific speed to determine yung right shape naman ng ating impeller or right design ng ating impeller na gagamitin. So once na makalculate natin yung specific speed required, then anything in between 10 to 30, it is desirable or it is recommendable to use a radial type impeller. So if it's more than 150 to 300, it is most suited to use the axial flow type. And if it's in between, then we need to use the mixed flow. So specific speed is important for us to determine which impeller shape ang gagamitin natin sa pag-design ng ating pump. So we discussed already the pump rating or pump sizing, including the motor rating. Ngayon naman yung tinatawag nating specific speed to determine the impeller shape most suited to the application. So ang formula niya is given on this. Specific speed is equivalent to the rotational speed multiplied by the discharge flow rate divided by the head raised to the 3/4. So yung ating discharge flow rate, kailangan natin siyang i-square. As you can see here, ang unit natin is revolution per minute multiplied by the square root of gallons per minute. Please remember this class kung ano yung unit na gagamitin and feet raised to 3/4. Kasi hindi naman siya makakalculate or makakancel out. Unlike sa iba nating equations wherein pwede natin gamitin yung unit to determine yung next step. Kasi kailangan cancel out yung iba. Halimbawa, hinahanap natin is in meter, then we need to convert everything, calculate it, at maiwan lang yung meter or yung power para makuha natin si kilonewton meter per second or kilowatt. While unlike for specific speed, it's nabanggit na dito na this is a dimensionless rating, meaning wala siyang unit sa specific speed. So we can assume that this is an empirical equation or acquired by the engineer during numerous testing or during numerous investigation. Kaya nakapag-acquire tayo ng ganitong equation. So please remember na lang siguro guys or class, yung unit na ginagamit natin dito, please use for rotational speed in RPM, discharge flow in gallons per minute, and in head into feet. Merong equivalent SI equation para dito or metric unit para dito. Wala pala akong makitang proper reference, kaya hindi ko muna siya binigay. So if makita ko siya by this week, baka i-present ko siya sa inyo on next week. Pero for now, if until wala akong bibigay, then you can use this equation and convert every unit into this unit. Please make sure na pare-parehas lang sila. Kasi hindi nyo pwedeng gawing reference yung unit to Another parameters that needs to be considered when designing a pump is what we call the affinity loss. Basahin mo natin si affinity loss, then saka ko explain para mas maintindihan natin. So affinity loss, the affinity loss can be used to predict the performance of the pump at different diameters for the same speed or different speed for the same diameter. The affinity laws of pumps indicate the influence on volume capacity, the head or the pressure, and or power consumption of a pump or fan due to if we change the speed of the wheel or revolution per minute in RPM, or in geometrical similarity, change the impeller diameter. Note that there are two sets of affinity laws. The first one is the affinity laws for specific centrifugal pump to approximate head, capacity, and power curves for different motor speeds and or different diameter or impeller. Next is the affinity laws for a family of geometrically similar centrifugal pumps to approximate head, capacity, and power curves at different motor speeds and or different diameters of impeller. So to explain it better, medyo marami-rami masasaulong formula when it comes to affinity laws kasi nga parang 14 formulas to. Oo nga. So it's up to you na lang siguro kung paano nyo memorize to ng mas madali. Pero I'll explain what is the purpose or para saan ba si affinity laws. So for example, we are working in a maintenance department. Then tinanong tayo ng ating supervisor na, okay, palitan natin ang existing na pump. Meaning meron ng existing na pump dito or there's an initial case, we can call that as initial case or existing na working na pump. So we already know the detail. When we say existing, gumagana na siya. So meron na tayong detail nung volume flow capacity. Meron na tayong details nung existing na rotational speed, the impeller size, the total head ng pump na gumagana, the power, at saka anong density ng fluid na dumadaan dito. Then, we are asked to do is, okay, sige, palitan natin yung speed ng pump na to. Meaning, palitan natin yung motor na ginagamit. Taasan natin yung revolution per minute niya. So, N2 here is greater than N1. Then what will be the effect kapag in-increase natin or tinaasan natin yung speed ng motor or ng ating pump na hindi natin binabago ang diameter ng ating impeller. So same impeller pa rin yung gagamitin natin, same pump, tinaasa lang natin yung speed natin. Diyan papasok na yung tinatawag natin na pump affinity loss. Hindi natin siya kailangan i-compute ng bago. Rather, we can use these following equations para ma-determine natin yung bagong magiging flow capacity, magiging head ng ating pump, at magiging power ng ating pump. So for example, this equation associated with the constant impeller diameter. So D2 is equivalent to D1 as you can see here. Pero variable ang ating speed, meaning dinoble natin ang capacity ng ating speed or depende sa kung anong ni-require. It's either binawasan natin, dinoble natin, will depend. We already know the initial condition or the existing condition ng volume flow capacity. We know the existing rotational speed and we are asked to double it. For example, doblehin lang. Example lang to. Then we can know the value already of our volumetric flow rate. So one equation, one unknown, we can solve the problem. Ganun din when it comes to the total head. Since we already know the existing total head ng ating pump, existing speed ng ating pump, and we are asked to double or twice the value ng ating rotational speed, then we can determine the value of the head ng ating pump using the affinity laws. So, ganoon din when it comes to power. Then what if naman binago natin yung ating impeller diameter? Pinalaki natin yung yung existing pump natin. Sinabihan tayo ng ating supervisor na, okay, can you calculate yung magiging effect sa volume flow capacity sa total head at sa total power kapag pinalaki natin or we increase the size ng ating impeller diameter while maintaining the um, speed ng ating motor. So hindi tayo nagpalit ng motor, same speed pa din yung ginamit natin. Then we can use the equation associated with letter B, the constant speed variable impeller diameter. Again, we have the existing value for the volume flow capacity kasi existing na siya. We already know the existing diameter ng impeller. Ngayon, inutusan tayong palitan ng impeller, make it bigger or make it smaller depending on the requirement. Then we can find the value of the new volumetric flow rate. One equation, one unknown, we can get or we can solve this one. Same goes kapag kinuha natin si head and same goes kapag kinuha natin si power. As long as we have the initial condition, given yung initial condition, existing condition ng pump, so magdidepend na lang kung babaguhin ba yung ating impeller diameter o yung motor speed natin dito. But what if naman, ang pinabago sa atin is yung magiging fluid properties o kung ano yung fluid na dadaan sa ating pump or sa ating piping system. So if initially binigyan tayo ng condition, volumetric flow rate, and initial density ng fluid, halimbawa from water, pilitan natin siya to oil, then ano yung magiging effect naman sa volumetric flow rate ng ating pump system. So makalculate natin yan using the equations associated with letter C. Constant speed, constant speed, then variable fluid density. Q sub 1 divided by Q sub 2 is equivalent to, this is density. Density ng initial na fluid natin divided by the density ng magiging bagong fluid natin. Then again, one equation, one unknown, makukuha natin ng value ng either volume flow rate, ng head, or ng power. So additional relation or affinity loss is using what we call the specific speed. So kanina, dinefine natin na what if nag-vary yung ating impeller diameter or nag-vary yung ating speed. But what if hindi natin sinabi na nagbabago yung impeller diameter natin? However, binigyan tayo ng rotational speed, initial rotational speed, initial volume flow rate, at initial head, total head ng ating pump. Then ma-acquire natin ang bagong speed, bagong flow rate, or bagong head ng ating pump using this equation. Or everything is associated here with the specific speed as long as dapat parehas yung ating ginagamit na unit. So this is used mostly for the similar pumps. So last set of equation for affinity loss is what we call the variable speed and variable impeller diameter. Ngayon naman, parehas nagbago yung speed mo, parehas nagbago yung impeller diameter. So binigyan ka ng panibagong details ng supervisor saying that, okay, change the impeller diameter and also change the speed ng motor natin o ng pump. Ano yung magiging effect nito or ano yung magiging bagong values ng ating volume capacity, ng ating total head ng pump at ng ating power. So we can use this equation to determine those variables. So given ang initial condition of volume flow rate, initial condition ng ating rotational speed, initial impeller diameter, bibigyan tayo ng panibagong situation which is, okay, palakihin mo or you make it twice the diameter ng impeller, make it twice the rotational speed, then we can find the value for the volumetric flow capacity. One equation, one unknown, we can solve the problem. The last one, same pa din, nag-add lang tayo dito ng density ng fluid. If same lang naman yung magiging density ng fluid na dadaan, then density 1 divided by density 1 is 1 as well. Pero kung magkaiba pa yung density, then we can use this equation. So clear ba tayo sa sa affinity loss? Medyo madami-dami yung equation si affinity loss. So it's up to you na lang siguro kung paano siya ma-memorize. Pero lumalabas to sa board exam, lumalabas to during our review. Inuulit-ulit yan. And even sa mga design interview, napapasama yan. So remember na lang natin yung paggamit ng affinity loss. Okay, in reality, pinag-usapan kasi natin kanina is we just discussed one type of pump sa isang system. But in reality, there are series or in parallel connection ng mga pumps depending on kung ano yung objective talaga natin. So let's just define muna anong difference ni series at saka ni parallel connection ng ating pump. So for series connection, mapapansin, makikita nyo on the right side ng ating slides. The pump can be considered in series kapag yung discharge niya, discharge ng first pump, this is first pump, then second, third, and fourth. Kapag ang discharge ng first pump mo ay magiging suction ng second pump, ang discharge ng second pump will be the suction of the third pump, discharge ng third pump will be the suction of the fourth pump. As you can see also in the picture below. So same lang naman yung pinagkukuhanan ng source or ng suction side. And same din yung pagbabatuhan ng ating discharge port here. So a centrifugal pump is said to be a multi-stage pump when more impellers are used to do a certain job for pumping. This impeller may be arranged as follows. So kapag pumping series, the objective natin dito is to increase the total developed head or the total dynamic head ng ating system. So we can get the value of the total head by multiplying the number of pump in series to the head developed by each impeller. If iba-iba yung head na de-develop ng each impeller, then what we can say is that the total dynamic head or total head is equivalent to head of the impeller 1 plus head of the impeller 2 plus head of impeller 3 and so on so forth depending kung gaano kadami yung nakakonect na pump in series. However, sa ganitong situation, kahit na namumultiply yung total head ng pump depending on the number ng pump in series, yung volumetric flow rate niya, total volumetric flow rate ng pump in series will remains the same or constant. Gaano pa kadami ang pump connected in series. So Q1 equals to Q total equals to Q3 and so on and so forth. So pump, we can say that pump is connected in series. Kapag yung discharge ng first pump will be the suction of the second pump, discharge ng second pump will be the suction of the third pump, and so on and so forth. While kapag ang pump naman is in parallel connection, they have the same suction line, suction collector, and they are on with the same discharge collector. So connected lang sa iisa sila sa isang reservoir yung pinagkukuhanan, connected din sa isang reservoir yung pinagbabatuhan natin ng fluids. So ang ating objective kung bakit natin ilalagay or ina-arrange yung pump in parallel is to increase the total flow rate ng ating system. So total flow rate ng system is equivalent to the number of identical pumps arranged in parallel multiplied by the discharge of one pump. So kapag iba yung kanilang flow rate, then again, Q total is equivalent to Q1 plus Q2 kung ano yung volume flow rate ng pump 1 plus volume flow rate ng pump 2. plus flow rate at pump 3, and so on and so forth. While for the head, fortunately, kapag nakaparallel ka, yung total head ng system or total head ng mga pumps mo will remain constant. So equal to H1 equal to H2. Okay, to summarize it, then ang objective nga natin kapag ang pump mo is naka-series is to increase the head. Then ang total head will be the summation ng lahat ng head ng mga pumps. While the volume flow rate is equivalent lang sa Q1 and Q2. Parehas lang sila ng volume flow rate. While kapag ang pump mo naman is connected in parallel, ang ating objective is to increase the volume flow. So, ang volumetric flow rate natin will be Q1 plus Q2 plus Q3 depending on gano'ng kadami nakakonect sa parallel, while our head is just constant or will remain the same. H1 is equivalent to H2. So next topic is what we call the net positive suction head. Again, our objective here is to design the proper pump according to the requirement ng system, according to the requirement ng industry natin. So kanina we discussed the right sizing or kung paano kino-compute yung fluid power, going back to brake power, then going to motor power. Na-discuss na rin natin kung paano kino-compute or kung paano natin malalaman yung tamang impeller type na gagamitin. It's either radial, mixed flow, or axial flow type by using the specific speed ng pump. Then, if we are given an initial condition or an existing pump, then pina-design tayo ng panibago, parameters na nababago is kung nagbabari ba yung speed or nagbabari ba yung diameter, then we can use what we call the affinity loss to determine the effect or yung change nito sa panibagong or sa newly installed na pump natin. Ngayon naman, we have what we call the net positive suction head. It's also part of ng pagde-design ng mga pump. Merong purpose to kung bakit kailangan natin makalculate si net positive suction head. But please be reminded as well na si net positive suction head is independent sa tinatawag natin na total dynamic head sa TDH. It should be emphasized that the calculation daw ng net positive suction head and the total pump head or total dynamic head must be kept separately. Huwag natin silang i-mix up kasi magkaiba yung purpose nila. Si total dynamic head is kino-compute para ma-determine natin ang fluid power, para ma-determine natin ang brake power and motor required. Well, net positive suction head ay meron iba ring purpose or objective. So before we define what is net positive suction head, define muna natin bakit nagkaroon ba or bakit ang mga engineers or mga designers is nag-come up sa net positive suction head. Ano yung kailangan nilang i-treat? Ano yung problem na nakita nila sa pump na kailangan natin i-treat para okay. Sorry. So ano ba ang nakita ng mga designer na issue sa pumps na nag-arrive sila or okay, kailangan natin makadetermine yung net positive suction head ng system para hindi na magkaroon ng ganito. So that is what we call the pump cavitation. Let me read it first, then i-define natin para mas madali. So pump cavitation is the formation ng bubbles at the pump inlet followed by the sudden collapse which can cause permanent damage. So let's just highlight here what is the term permanent damage. So may issue daw si pump cavitation na nakaka-damage pa sa ating pump. So, pump works by creating a pressure differential between the inlet and the outlet. The high pressure at the inlet causes fluid to flow toward the low pressure at the outlet. So we know that the fluid flows from the high pressure going to the lower pressure. So if the pressure at the inlet falls below the vapor pressure of the fluid, highlight din natin yan, falls below the vapor pressure of the fluid, then the bubbles will form at the inlet. This bubble collapses inside the pumps as they move towards the outlet. So that's what we call the pump cavitation. And the cavitation causes the pump to first is to operate noisily, making it sound like something like gravel in a concrete mixer. Next is the bubbles in the fluid also reduces the capacity ng pump. And lastly, most importantly, cavitation removes small spots of material from the inside walls of the pump, pitting the walls and causing permanent damage to the pump. So again, permanent damage to the pump. Kailangan nating iwasan si pump cavitation para hindi makasira ito sa ating pump. Since pag nasira si pump, it will be additional cost, additional losses sa ating industry. So cavitation occurs more readily at higher temperatures since the vapor pressure increases with temperature. Sinasabi rin dito na si vapor pressure is dependent or directly proportional to the temperature ng fluid. So the higher the temperature, the higher will be the fluid pressure, the vapor pressure. So this is temperature, this is pressure ng vapor. They are directly proportional to each other. And ang intention nga natin is to ensure na yung um, pressure at the inlet doesn't fall below the vapor pressure. Unfortunately, sa industry, yung mga temperature ng fluid natin dito matataas lalo kapag gumagamit ng or lalo kapag nasa power plant tayo wherein talagang ini-steam natin yung fluid or dumadaan dito is from the turbine kung saan yung fluid after the turbine napakainit doon. So may chance talaga na tumaas yung vapor pressure kasi nga tumataas yung temperature ng ating fluid. So yung pump decider use net positive suction head na tinatawag or NPSH to ensure that pumps will operate without internal damage caused by cavitation under all specified operating conditions. So yung kakalculate natin dito or before NPSH is madi-define daw sa dalawa. First one is the net positive suction available and next is the net positive suction head required. So pag sinabi natin available, it is the absolute at the suction point of the pump. When we're discussing net positive suction head, we need to use the value of pressure as absolute. So if this is a pipe, any pressure na ma-register sa ating pressure gauge, this is a unit of pressure gauge. This is gauge pressure lang. So to make it an absolute pressure, kasi ni-require tayo dito na calculating net positive suction head available, kailangan natin siya is absolute pressure. We need to convert it into absolute pressure, yung makukuha nating value ng gauge pressure. So plus, paano nga i-convert si gauge pressure to absolute pressure?
Mag-a-add po ng atmospheric pressure.
Okay. So kapag ang pressure natin is in PSI, then we need to add 14.7 sa ating gauge pressure. If it's in PSI, then we need to add 14.7 sa ating gauge pressure to make it absolute pressure. Then kapag KPA naman, we need to add 101.325 to make it absolute pressure. So once again, kapag pinag-uusapan natin is net positive suction head, kailangan natin i-convert ang gauge pressure na gagamitin natin into absolute pressure. Pero bakit hindi natin ito ginawa kapag nagko-compute tayo ng energy balance ng total dynamic head? Kasi let's extract this equation muna. So if PD or pressure discharge plus 14.7 i-minus natin siya the suction side plus 14.7. So basically, parang sinubtract din natin yung 14.7 both sides. Kaya kahit hindi natin gawin siya during the energy balance or pagkuha ng ating total dynamic head, okay lang, tama pa rin naman yung magiging result natin. Unlike kapag sa pagkuha natin ng net positive suction head. Kasi kapag when we're discussing net positive suction head, ang pinag-uusapan lang natin dito is on suction part. Hindi natin dito sinasama sa calculation yung ating discharge. So pamaya sa equations, sa formula, makikita natin kung bakit ganun. Okay, to calculate the net positive suction head, ang equation is that H sub P or the pressure head plus or minus the elevation head or H sub C, everything here is at the suction point only, minus the vapor pressure minus the friction losses, which is H sub F. We can also say that H sub P plus if given yung velocity at the suction, then we can add as well the velocity here. Sorry, hindi ko siya naisama. So H sub P is the head corresponding to the absolute pressure on the surface of the liquid from which the pump draws, meaning sa suction side lang. This will be the atmospheric pressure corresponding to the altitude of the unit if the tank is open, or the absolute pressure in the heater or closed tank from which the pump takes liquid. While H sub C is the height of the liquid surface above or below the impeller center line. So kukunin lang natin dito is on the suction side. HVP, represented by the vapor pressure, is the head corresponding to the vapor pressure of the liquid at the existing temperature. It is expressed as absolute pressure. While H sub F is the head loss because of the friction and turbulence between the surface of the liquid and the pump suction flanges. So let's treat it separately with the total dynamic head kasi iba nga yung purpose nila. Net positive suction head is ginagamit to treat or maiwasan natin ang pump cavitation. And everything here, not everything here, the pressure head and the vapor pressure must be calculated in absolute pressure only. So if we are given in the problem, or the problem gives in the suction side the velocity head, then we can add as well the head, the velocity head in this equation. Okay, para hindi ko makalimutan, I think na-miss out kong sabihin, si net positive suction head required or NPSHR is usually given by the designer, usually given by the supplier. So, ang purpose lang or intention lang o kailangan i-compute lang ng mga engineers, ng mga kagaya nyo, is to determine the net positive suction head available sa system. So, kailangan nyo lang calculate sa system ano yung net positive suction head available. Then, para maiwasan natin ang pump cavitation, net positive suction head must always be higher than the pump's negative net positive suction required. So NPSH must be greater than NPSHR. So once nakuha nyo na, or nakuha na ng mga engineers ang value ng NPSH na available sa system, maghahanap tayo or maghahanap kayo ng right size ng ating pump, which is greater than dapat yung net positive suction head available dun sa binibigay ng designer or ng supplier na net positive head suction required ng pump na yun. So kapag pinili natin is mas mababa, halimbawa may nakita, ang na-acquire natin value ng net positive suction head is in 50 meters. Then ang kinuha nating value ng net, kinuha nating pump ay mayroong rating na net positive suction head required niya is 60 meters. Then cavitation may occur kapag in-install natin yung pump into the system. So ang kailangan natin kunin is yung pump na mayroong value ng net positive suction head required na mas mababa, less than 50 meters dapat. So as a general rule daw, general guide lang naman to, make sure that the net positive suction head required is less than the net positive suction head available by a larger of 5 feet or 10% of NPSHA. For example, if the net positive suction head required is 10 feet, then the available must be at least 15 feet. Okay, so this is a table to show the relationship between the vapor pressure ng ating fluid or ng water sa sa temperature niya. So kung makikita natin, the more na tumataas yung ating temperature ng fluid or ng water, so tumataas din yung vapor pressure. Okay, do we have questions regarding that? Kung anong intention, kung anong objective sa pagkuha ng net positive suction head. Sana clear sa inyo na they are treated independently. Sa pagkuha ng net positive suction head and the total dynamic head, they must not be mixed up kasi magkaiba nga yung kanilang purpose. Okay, so we'll finish the reciprocating pumps, then we can move on to our sample problems after this. So kanina, na-define natin, mostly naman yun is applicable to centrifugal pumps. So what if reciprocating pumps naman yung pinag-uusapan? If we are dealing with reciprocating pumps, then we need to deal with what we call as volumetric efficiency. Sa centrifugal pump, ang pagkuha ng efficiency natin is by using the output power divided by the input power or output energy divided by the input energy. Pero kapag reciprocating pumps, we are dealing here on what we call as volumetric efficiency o yung actual discharge natin or actual volume na displays against or in reference to the theoretical flow or the piston displacement na tinatawag. So volumetric efficiency in a hydraulic pump refers to the percentage of actual fluid flow out of the pump compared to the flow of the pump without any leakage or theoretical flow. Pero same ano pa rin naman, same condition, efficiency shall be multiplied to 100 to make it in percentage, then yung output divided by input pa din. Yun nga lang, iba yung reference natin compare sa reciprocating pump, sa centrifugal pump. Kasi centrifugal pump, ang ginagamit nating unit dito is in energy or in power. While for reciprocating pump is in volumetric efficiency. So output divided by input pa din naman. Ang output nga lang natin dito will be the actual discharge or ito yung volumetric flow rate ng ating fluid divided by the piston displacement. Later, we will define ano ba yung piston displacement at paano siya nakukuha. Pero piston displacement is the theoretical flow without leakage. So itong volumetric or ito yung actual discharge is the piston displacement minus leakage. And later, makikita natin na hindi leakage ang tawag when it comes to volumetric efficiency or reciprocating pump. Ang tawag sa kanya is slip, S-L-I-P. So, volumetric efficiency is the most common metric used in turbine and hydraulic pump condition based on an increase in internal leakage caused by wear or damage. So again, pagkuha ng actual discharge, simple lang naman. Actual discharge is equivalent to area multiplied by the velocity. Yung area na gagamitin natin dito will be the area ng ating cylinder. Area ng ating cylinder or diameter will be this one. For single acting, same pa din, ito yung magiging diameter na i-consider natin. So we have two types ng reciprocating pumps, the single acting reciprocating and the double acting reciprocating pump. To differentiate them, makikita nyo naman sa figure on the left side is a single acting reciprocating pump. So for every one complete revolution ng ating crankshaft, or this one, or for every one complete revolution ng ating piston, there will always be one suction. Isang beses na nagkakaroon ng suction at isang beses na nagkakaroon ng discharge. Ito yun. One discharge and one suction for every one complete revolution ng ating piston. While for double acting reciprocating pump, for every complete revolution ng ating piston, napunta siya dito sa taas, bumalik siya sa bottom, there will always be two discharge and two suction. So we can say that theoretically, the volume flow rate of the double acting reciprocating pump is twice the volume flow rate ng ating single acting reciprocating pump if hindi natin ko consider ang diameter or ang space na nako-consume ng piston rod. Ito natin siya mas may specify. So the piston displacement, ito nga yung theoretical flow na tinatawag or PD, is the volume displaced by a piston in a cylinder. So para makuha natin ang piston displacement sa centrifugal sa reciprocating pump, then we need to multiply the pi d squared over 4 times the length ng stroke times this, the speed, which is in RPM. Length ng stroke is this one. Then for double acting reciprocating pump, kapag nilagdag natin yung piston rod, ito yung sinasabi ko kanina, we just need to multiply the value initially, pi d squared over 4 times the length ng stroke or sa haba ng piston natin or ng cylinder, then multiply it by 2 only. Then we can arrive with this equation, pi d squared over 2 times L times N. While for double acting reciprocating pump, kapag i-consider natin yung piston rod, kasi kung makikita natin dito, the piston rod still consumes space, consumes volume here. So, kung hindi siya sinabi sa problem na neglect the piston rod, then kailangan din natin makalculate ano ba yung losses or ano ba yung nakukonsume na space doon para makuha natin yung actual na piston displacement. So to do that, we just need to add the original one or the initial, which is pi d squared over 4 multiplied by length ng stroke multiplied by the speed plus the difference in the diameter ng cylinder and the piston rod multiplied by the length of stroke and the RPM. So ito yung ito yung equation natin kapag kukunin natin ang piston rod, kapag kailangan i-consider ang ating piston displacement kapag kailangan i-consider ang piston rod at kapag dinineglect natin yung body ng piston rod. So last, when we discuss about reciprocating pump, we need to discuss what we call the percentage slip. So slip in reciprocating pump is basically defined as a difference between the theoretical discharge and the actual discharge of the reciprocating pump. So this is equivalent to what we call slip, AD minus Q, or the theoretical minus the actual. We call that losses in the centrifugal pump, but for the reciprocating pump, we call that slip. So percentage slip is just the difference between the theoretical minus the actual divided by the theoretical, which is PD minus Q over PD divided by times 100. This is we called 1 minus efficiency or Q over PD, or volumetric efficiency here. Equal din sila dito. So okay, next topic before we move with our sample exercise, let's just compare muna ano ba yung advantage ng reciprocating pump against centrifugal pump or yung disadvantage nila parehas. Or let's compare them both. So in comparison between centrifugal pump and reciprocating pump, we need to consider the cost, maintenance, option, and the usage. Kasi nga, ang intention natin dito o yung ating objective is to determine yung right type ng pump, right size ng pump, right classification ng pump na gagamitin natin sa ating design o sa ating system. So generally, this is just a guide. Siyempre, maraming parameters involved. Pero in general, when it comes to cost and maintenance, it is favorable daw to use centrifugal pump kasi nga it's very simple and there's very less moving parts that can get worn out. Besides, they are also easy to install and their repairing takes less time comparatively. They are also cheaper compared to reciprocating pumps. On the other hand, compared to centrifugal pumps, there are more moving components in reciprocating pumps, which means there is more wear and tear and they require extra maintenance. So when it comes to cost and maintenance, it is favorable or desirable to use centrifugal pumps. When it comes to capacity, centrifugal pumps can handle high viscosity liquid like oil or muddy water, while reciprocating pumps only handle low viscosity liquid. So when it comes to capacity, mas favorable pa rin to use the centrifugal pump. Compared to reciprocating pumps, centrifugal pumps have uniform torque and output and are safe to be used at high speeds. Also, centrifugal pumps have higher capacity and it can only be increased if the inlet and outlet diameter are made larger. For efficiency, baliktad naman, mas mataas ang efficiency ni reciprocating pump, ranging from 85% or more in compared to the centrifugal pump, kung saan ang efficiency niya is between 30% to 60% lang. Accordingly, since mas mataas ang efficiency ni reciprocating pump when it comes to energy consumption, mas favorable gamitin si reciprocating pump. Kasi centrifugal pump generally uses 1.4 to 1.9 times as much as energy as the reciprocating pump. If the centrifugal pump works at less than 30% efficiency, when its system performance does not match the pump performance, then the energy consumption might be as high as 2.2 to 3 times. So, when it comes to efficiency, when it comes to energy consumption, mas favorable gamitin si reciprocating pump. While for the usage, multi-stage centrifugal pumps are often preferred in operation with large volumes and low pressure, while reciprocating pumps are frequently favored for application requiring high pressure and low volume. Additionally, large quantities of liquid can be handled by centrifugal pumps, whereas a reciprocating pump can handle less liquid with these valves and reciprocating action. So when it comes to usage, applicable to use is, or desirable to use, will be the centrifugal pumps. Okay, so before we move with our example problem, um, any clarifications, questions?
None so
Wala
far po.
naman.
Done po, sir.
Let's have let's have a break muna by 15 minutes siguro. We'll return by 4 p.m. Then we can continue with our exercises. Please message me kapag may mga questions kayo. Thank you.
Sige po, sir. Thank you po. Sir, excuse po. Sir, hindi po namin kayo naririnig. Sir, good afternoon po. Sir, hindi po namin kayo naririnig.
Hello?
Rinig na po, sir.
Okay na ba? Can you type it? Actually, hindi ko makapit na editing masyado eh.
Rinig na po, sir.
Sorry, Miss Claudine, hindi ko talaga siya nagkakaroon ng feedback sa ano eh. Okay na. Sige, sige. Thank you. So, let's continue. So, kagaya na sinabi ko, yung problem 1 natin na to, or the next 3 problems natin is kinuha ko lang previously sa inyong mga previous quizzes sa mga old proctor nyo. So, if familiar to, mas maganda. Pero let's discuss pa rin naman kung paano natin na-solve. Ang importante naman dito is yung analysis ng problem given. Sa mga hindi pa familiar dito, at least madi-discuss natin kung paano siya i-solve. So let's read it together and let's solve it together. So just let me know kapag may tanong kayo sa or clarification sa magiging solution o sa magiging answer. So problem 1.0, water is pumped to a height with a total head of 39.36 meters. The available power is 60 cycles, 220 volts, and 3 phases. Find the horsepower of an electric motor to drive a centrifugal pump at 3,450 RPM, having a discharge pipe of 2 inches. Assume a water flow velocity of 5 feet per second and 70% pump efficiency. Find the monthly billing if the pump is running at 30 days at 20 hours per day in operation. The cost of electrical energy is 2.6 pesos per kilowatt hour, and assume the motor efficiency of 85%. So first, let's list muna kung ano yung mga binigay sa problem, kung ano yung mga given. So the first thing here is that the total head, which is total dynamic head, is equivalent to 39.36 meters. The speed of centrifugal pump is 3,450 RPM. The diameter at the discharge port or the discharge part is in 2 inches. Binigay din siya yung diameter ng ating discharge flange. The velocity is 5 feet per second. Efficiency ng pump is 70%, while the efficiency ng motor is 85%. Ng cost ng electricity is given din at 2.6 pesos per kilowatt hour. So yung hinahanap, we need to determine the motor power in HP. Kasi yung hinahanap is find the horsepower of an electric motor to drive a centrifugal pump. So unit din ng power must be in HP, not in kilowatt. Pero for the sake na mapadali yung ating calculation, we'll do it first in kilowatt, then saka natin i-convert to in HP.